Hi, I am Sanjay Patel. In this video, we are going to solve problems based on the successive differentiation formulae what we have derived in our earlier lectures. For the reference, I have made a list of all the formula or the results we have derived for nth derivative of some standard functions. Like y is equal to e raised to x plus b, then its nth derivative yn is a raised to n times e raised to x plus b. You can also make the list of all these formulae and then start solving the problems. We'll see some nice problems based on all these formulas for understanding how to apply these formulas. And after one or two lectures, we'll be understanding how to apply the Leibniz theorem to find the nth derivative of product of two functions. So let us begin with the first problem here. So let me write as the first problem is if you have y is equal to say 2x plus 3 upon x square minus 5x plus 6, then find the nth derivative of this function. Okay, and also find y and 0. That means the value of nth derivative at x equal to 0. So let us solve this. In our that formula list, we do not have the nth derivative formula for such a function. So what we are trying to do in all the problems is we'll try to convert the given function or expression in terms of the known functions whose nth derivative is we have derived in our videos. Okay. So first of all, it is a rational expression. Numerator is a polynomial and denominator is also a polynomial. So we can use we can split this using method of partial fractions. So we consider this rational expression 2x plus 3 upon x square minus 5x plus 6. The first step is we can factorize the denominator. Here you note that the degree of the numerator polynomial is 1 and degree of the denominator polynomial is 2. So we can use the method of partial fraction here. First factorize this into linear factors. So x minus 3 into x minus 2, it is very simple. 3 to the 6 and minus 3 and minus 2 is minus 5. So this way you can factorize. And then this we can express in the form something upon x minus 2 plus something upon x minus 3. Okay, so this we have to find what is a and b by comparing these two expressions. So if you take the LCM here, you will get x minus 2 into x minus 3 and the numerator will be a times x minus 3 plus b times x minus 2. So we can write 2x plus 3 as a into x minus 3 plus b into x minus 2. The technique is known to you when we have solved the problems of integrations in using the method of partial fractions. Now to find the value of these constants, as this is valid for all x belongs to R, you can take any value of x and find out the value of the unknowns a and b. So what I am going to do here is, let us take x is equal to 2. So if I take x is equal to 2, then in the left hand side we will get 2 into 2 is 4 plus 3. Let me write. This is equal to a into 2 minus 3 plus b into 0. So that gives us that left hand side is 7 and the right hand side is a into minus 1. So that gives me the value of a is equal to minus 7. This is the first constant I have obtained. It is not compulsory that you take x equal to 2 only. You can take any value of x. Okay, and then sometimes you will get two equations. You can then solve those equations and find the values of a and b. But this is an easy observation. Taking x equal to 2, this constant b automatically goes, and we can find the value of a directly. If x is equal to 3, now again by observation you can see if you take x equal to 3, this term goes, so I can get the value of b directly. So putting x equal to 3 here, left hand side is 2 into 3 plus 3, that is 6 plus 3 is equal to 9, and the right hand side is a into 0 plus b into 3 minus 2, that is 1. So that gives me the value of b is equal to 9. So this suggests that this expression 2x plus 3 upon x square minus 5x plus 6, which is equal to this, and it is expressed in this form, a upon x minus 2 plus b upon x minus 3. I can put the values of a and b in this so that I can express this in terms of partial fraction. So therefore from 1 we can write 2x plus 3 upon x square minus 5x plus 6, which is actually our y, this as a upon x minus 2, that is minus 7 upon x minus 2 plus b upon x minus 3. This is b upon x minus 3 and b value is 9. So it is 9 upon x minus 3. Okay. Now we can take the nth derivative on both the sides, and we have the formula for such an expression 1 upon ax plus b. So we always write after getting the standard form as taking nth derivative on both the sides. We get left hand side is y, its derivative is nth derivative is yn, and this is equal to the nth derivative of this. This minus 7 is in multiplication, so I will write like this: minus 7 into the nth derivative of this expression 1 upon x minus 2, its nth derivative, plus again 9 is a constant in multiplication, so this I can write as 1 upon x minus 3, the nth derivative of this. Now let us recall that formula what we have derived. We have, if y is equal to 1 upon ax plus b, then its nth derivative yn is given by minus 1 raised to n factorial into a raised to n upon ax plus b raised to n plus 1. So we have, in these two brackets, both the expressions are of this form 1 upon ax plus b. Here a is equal to 1 and b is equal to minus 2. In the second bracket, we have a is equal to 1 and b is equal to minus 3. So putting all the values in this formula, what we can write is the nth derivative easily. So this implies yn is equal to minus 7. We have here a is equal to 1 and b is equal to minus 2. So I can write this as minus 1 raised to n into n factorial into a, that is 1. So 1 raised to n upon x minus 2 raised to n plus 1 plus 9 times minus 1 raised to n factorial. And what is a in this case? Here also a is equal to 1 and b is equal to minus 3. So we get 1 raised to n upon x minus 3 raised to n plus 1. So this we can simplify and write it as n factorial minus 1 raised to n, which is common in both, and it is minus 7 upon x minus 2 raised to n plus 1 plus 9 upon x minus 3 raised to n plus 1. Okay. So this is our nth derivative of the given function 2x plus 3 upon x square minus 5 plus 6. So this is giving us the value of the nth derivative at any point x. But we are interested in finding also the value of say yn 0. So I can say yn 0 means we have to put this value of x equal to 0 in this. So yn 0 is equal to minus 1 raised to n into n factorial into minus 7 upon putting x equal to 0 here, we get minus 2 raised to n plus 1. And here plus 9 upon putting x equal to 0 here also, we get minus 3 raised to n plus 1. Okay. Just we can simplify this as follows. The minus 1 raised to n, if you take inside, you can write this as n factorial. Okay. So this will be cancelled because minus 1 raised to n into minus 1 is minus 1 raised to n plus 1. That will go with this, and what you will get is 7 upon 2 raised to n plus 1. Okay. And here minus 1 raised to n and this minus 3 raised to n plus 1, as you know, we can write it as minus 1 raised to n plus 1 into 3 raised to n plus 1. So this minus 1 raised to n will be cancelled with this minus 1 raised to n. And what you will get is 9 upon 3 raised to n plus 1. And that 1 minus 1 which is left here, minus 1 into minus 1 raised to n, this minus 1 I am writing over here. So this is our value of yn 0, and that is our final answer. Okay. Let us solve another interesting problem based on this formulas. Consider the second example. If y is equal to x raised to 4 upon say x minus 1 into x minus 2 is given, then find the value of the nth derivative. Okay. So in this, first of all, you note that this is again a rational expression. Numerator is a polynomial and denominator is also a polynomial. But this time, degree of the numerator is greater than degree of the denominator, because if you multiply these two, you know you will get a quadratic polynomial. Okay, so let me write this way first. The solution y is equal to x raised to 4 upon x minus 1 into x minus 2, which is same as x raised to 4 upon, we can multiply this, so we'll get x square, and minus 1 plus minus 2 is minus 3 times x, and minus 1 into minus 2 is plus 2. So you will get this thing. So numerator degree is 4, denominator degree is 2, and therefore we must divide the numerator by denominator and express in the improper rational expression form. Okay, so what we do is, to convert into this partial fraction, first we have to divide, which we have studied in school. I will divide this in this way. Let us put x raised to 4 here and divide it by x square minus 3x plus 2. Okay, square minus 3x plus 2. Now first, to get x raised to 4, we have to multiply this by something so that one of the term is x raised to 4 here. So what I will do is I will multiply this by x square. So x square into x square becomes x raised to 4. And that with what you are multiplying, we write over here with the same sign I should get. So x square into x square is x raised to 4 plus x square into minus 3x gives you minus 3x cube, and plus 2x square, and this we subtract. Okay, and we subtract these two, so we have to change the sign of this, minus, plus, and minus. You know this division process, so this will be cancelled, and what you will get is 3x cube minus 2x square. Okay, now next step, we have to multiply this divisor with something so that we get one of the term as 3x cube. Okay, so we want 3x cube there. So I want 3 into x cube if I multiply this with something. So it is clear that if I multiply this with 3 into x, so what I'm going to do is I will take 3x multiplied by this divisor. So this 3x I will write here. I am multiplying with plus 3x. So it is 3x cube. 3x into x square is 3x cube minus 9x square plus 6x. Now again we have to subtract these two. So we change the sign here. So this is minus, this minus becomes plus, and this is minus. And now this will be cancelled when you add these two. 9 and minus 2 is plus 7x square and minus 6x. So we get this thing. We know we have to continue the division process until the degree of the remainder, this is the remainder term, the degree of the remainder polynomial becomes less than the degree of the divisor. So here it is x square, and still we have the degree 2 in this remainder. So we must again continue the division process. In the next step, I am going to multiply this with something so that I get plus 7x. Suppose there is a minus 7x square, then I should multiply this by minus 7 only, so that I will get minus 7x square. Okay, so let us multiply this with 7. So what I am going to do now is 7 times x square minus 3x plus 2, so that I will get one of the term as 7 into x square. So I am writing here 7x square minus 21x plus 7 into 2 is 14. Okay, and now we subtract these two, and for that we have to change the sign of this. So I will write minus plus minus. So this will be cancelled, and plus 21 minus 6 is 15. This is plus 21x and minus 6x. Adding these two will get plus 15x and minus 14. Now we do not have to divide further because the degree of this remainder is 1 and degree of the divisor polynomial is 2. So we stop the division process. And you know this very well, when in the division process, whether it is for integers or for polynomials, using the division algorithm, whenever you divide a by b, and if the quotient is q, and if the remainder you get is r, then you can always write a is equal to b into q plus r. Okay, and from this is the statement of division algorithm theorem, very important result in mathematics. So this I can write as a upon b, because the divisor b with which we are dividing can never be 0. So a upon b is equal to a upon b is equal to q plus r upon b. So this suggests any expression of the form something upon something you can write as the quotient plus remainder upon the divisor. So this x is to 4 upon x square minus 3x plus 2 we can write as follows. From the above division process, what we can do is this. Therefore, x is to 4 upon x square minus 3x plus 2, this thing, which is actually y. So I am writing y here also. This y we can express as the quotient. This is the quotient. This is the divisor, which is b. This x is to 4 is a, and this is your remainder, that is 15x minus 14. So quotient, that is x square plus 3x plus 7 plus remainder, that is 15x minus 14 upon the divisor, which is x square minus 3x plus 2. Okay, so we can write like this. Now let us call this as the result number 1. Okay, let us call this as result number 1. What I am going to do is this y is equal to this thing. Still I want to express in terms of partial fraction. So I will separate this x square minus 3x plus 2 because I do not have a formula for nth derivative of 1 upon this kind of polynomial, that is ax square plus bx plus c type. So again we consider 15x minus 14 upon x square minus 3x plus 2 is equal to this you can factorize as x minus say 2 into x minus 1. So I can write it as a upon x minus 2 plus b upon x minus 1. I am writing directly here. Now comparing the two sides, we can express this as 15x minus 14 is equal to a into x minus 1 plus b into x minus 2. Taking the LCM and then simplifying and comparing both the sides, we get this. Now finding the values of a and b by taking different values of x. So if we take x is equal to 2, we get 15 to 30 minus 14 here, a into 2 minus 1, that is 1, and b into 0. Okay, so that gives me a is equal to 16. So 30 minus 14 is 16. So I am getting the value of the constant a as 16. Next, if we take now x is equal to 1, then this will be 15 minus 14 is equal to a into 0 by putting x equal to 1 here and x equal to 1 here. We had b into minus 1, and that gives me this 15 minus 14 is 1, but because of this minus 1 here, we'll get b is equal to minus 1 finally. You can simplify this and you will get these two constants. Now substituting these values of a and b in this expression, and that finally we replace this term here by a upon x minus 2 plus b upon x minus 1. So what I get here is this thing. So therefore y, this function y is equal to x raised to 4 upon x square minus 3x plus 2, which is equal to this, becomes x square plus 3x plus 7 as it is, plus this 15x minus 14 upon this thing which we have derived here as a, that is 16 upon x minus 2 plus b, that is minus 1 upon x minus 1. So I can write this expression as 16 upon x minus 2 minus 1 upon x minus 1. Now everything is in the required form because we have 1 upon x plus b type of function over here in these two places, and this is a simple polynomial whose any order derivative we can find very easily. But again, recall that this is a polynomial of degree 2, so its first derivative will be 2x plus 3, second derivative is 2x, and the third derivative is 0 and onwards. All the derivatives after 3 onwards of this x square plus 3x plus 7, this part is 0. Okay, so it is easy to find the first two derivatives for this function. So what we are going to do is we put a condition. Okay, if you take the third derivative or any higher derivatives, then what you will get is this. So taking nth derivative on both the sides, we get yn here, and the derivative of this I am writing as 0, assuming that the value of n is greater than or equal to 3. If n is 3 or more, the derivative of this second degree polynomial is always 0. So 16 upon x minus 2 derivative of this nth derivative plus, or rather minus 1 upon x minus 1 its nth derivative. Here we are assuming that n is greater than or equal to 3. This is important thing. Okay. Now next, it remains to just apply that formula of nth derivative of 1 upon ax plus b. So this becomes, now we know that formula, I will not write again. We have also mentioned that the derivative of 1 upon ax plus b in our previous example. Let me just show you. It is here. If we have y is equal to 1 upon ax plus b, then yn is equal to minus 1 raised to n factorial a raised to n upon ax plus b raised to n plus 1. So using this formula, we can simply write down the derivative of this term, that is minus 1 raised to n into n factorial into a raised to n. A is equal to 1, so I am not writing it, upon ax plus b, that is x minus 2 raised to n plus 1, according to the formula of 1 upon x plus b nth derivative, minus 1 raised to n into n factorial upon, again we have x minus 1 raised to n plus 1. So this is the nth derivative of the given function if n is greater than or equal to 3. For n is equal to 1 and 2, one can directly differentiate this and find the value of the derivative, first derivative and second derivative. So this formula gives us third derivative onwards. Okay, and this completes this problem. Let us solve the next problem, number 3. If y is equal to square root of 2x plus 3, then find the value of y7 of 3. Okay. Now just recall that we have already derived a formula for ax plus b raised to m, where m is any real number, of finding the nth derivative. If y is equal to ax plus b raised to m, okay, where m is any value, not necessarily integer, then its nth derivative yn is given by m into m minus 1, m minus 2 up to m minus n plus 1 into a raised to n into ax plus b raised to m minus n. This formula we can use for finding nth derivative of ax plus b raised to m, where m is any rational number or some real number. Okay. In our case, we have a is equal to 2 here, b is equal to 3, and m is equal to 1 by 2, because 2x plus 3 square root means 2x plus 3 raised to 1 by 2. And we want to find seventh derivative. So we want to find n is equal to, means we have n is equal to 7 in this formula. So the last term, that is m minus n plus 1, this will be m is equal to 1 by 2, n is equal to minus 7. So we can write minus 7 plus 1. Simplifying this, so what we'll get is 2 7s are 14, minus 14 plus 2 is minus 12 plus 1 is minus 11 by 2. So starting with this first value of m, we have to reach up to minus 11 by 2. So putting all the values here, what we get is y7 at any point is equal to m is equal to 1 by 2. So I am putting m is equal to 1 by 2 in this formula. M by 1 by 2 minus 1, 1 by 2 minus 1, then 1 by 2 minus 2, okay, that is minus 2, and 1 by 2 minus 3, and we have to go up to what? Minus 11 by 2. Every time we are removing 1 here, into a raised to 1, a raised to n. A means in this case it is 2, so it is 2 raised to n into 2x plus 3 raised to 1 by 2 minus 7, because n is equal to 7 is there. Okay. So further, if we simplify, what we get is y7 is equal to 1 by 2. 1 by 2 minus 1 is minus 1 by 2. And again we subtract minus 1 every time. Minus 1 by 2 minus 1 is, means just we have to subtract 1 each time in the previous term. So minus 1 by 2 minus 1 is minus 3 by 2. Minus 3 by 2 minus 1 is minus 5 by 2. Then minus 7 by 2, minus 9 by 2, and minus 11 by 2 into 2 raised to n into 2x plus 3 raised to, this is minus 14 plus 1, so it is minus 13 by 2. Okay. So this is our value of the seventh derivative, and we have to put x is equal to I think 3. Let me check. Yes, it is x equal to 3. We want the value of the seventh derivative at x is equal to 3. So we put x equal to 3 here in this and simplify, and that is our final answer. Putting x equal to 3, we get y7 of 3 is equal to, this we can simplify. How many times minus sign is that? 1, 2, 3, 4, 5, 6. It is 6 times, so it is plus, and numerator is 1 into 3 into 5 into 7 into 9 into 11 upon we have 2. So 1, 2, 3, 4, 5, 6, 7. So 2 raised to 7. Okay. This is 2 raised to 7. 1, 2, 3, 4, 5, 6, 7 into 2 raised to n into 2x plus 3. So 2 into 3 plus 3. Just note that we are putting the value of x in this place. So this is our final answer. This I can write as 1 into 3 into 5 into 7 into 9 into 11 by 2 raised to 7 minus n into 3 to the 6 plus 3, that is 9 raised to minus 13 by 2. Okay. Let us go to the next problem. Okay. So the next problem is number 4. It is based on that nth derivative of log formula. If y is equal to log of 4x square minus 9 to the base e is given, then find the value of yn. Just find nth derivative. Find yn. So let us solve this. We just recall the formula here. If y is equal to log of ax plus b to the base e, then its nth derivative, which we have derived as minus 1 raised to n minus 1 into n minus 1 factorial into a raised to n upon ax plus b raised to n. Okay. So this is the formula to find derivative of log of ax plus b. So this argument must be only a linear polynomial, while in our case this is a quadratic polynomial. So we apply some simple technique and convert this into a known function. So here I can write y is equal to log of 4x square minus 9 to the base e as log of 2x minus 3 into 2x plus 3. So first of all I am factorizing this, and we know log of a into b we can separate as log of a plus log of b. So this I am writing as log of 2x minus 3 plus log of 2x plus 3. Even if I don't write the basis, it is understood that the base is always e unless it is mentioned specifically. So now we can apply this formula star for finding nth derivative of log of ax plus b. So this gives us yn is equal to minus 1 raised to n minus 1 into n minus 1 factorial, then 2 raised to n, this is a, and this b is minus, b is equal to 3, minus 3 upon 2x minus 3 raised to n plus, for this formula, for this function, a equal to 2 and b is equal to minus 3. So we get the same thing, minus 1 raised to n minus 1 factorial, 2 raised to n upon 2x plus 3 raised to n. So this is the answer. You can take this outside and write 1 upon 2x minus 3 raised to n. Otherwise, this is fine. So this way we'll solve different problems based on say 1 upon ax plus b formula, then log of ax plus b, and also ax plus b raised to any rational or irrational powers. Okay. In the next lecture, we are going to solve problems based on some trigonometric functions and the derivative formula. Thank you.